Hi, this is Allison. I'm filming my experiment for Science Methods 330. Alright, and in this one is a candy engineering lab, and what we were instructed to do was to make different types of figures using gummy bears or some type of candy or marshmallows. I chose gummy bears and toothpicks. And what I did was I made two different types of shapes. I made a cube and I made a pyramid figure. And you can see, I went ahead and already did them because it kind of took a second to do it. But you can see there's the gummy bears and they all have the toothpicks stabbed through them. And I also did the same thing with the cube. Alright. And yes, I have like a square and then they all meet at a point at the top. I made 3 of these as instructed from the instructions because you can't just balance 1 on 1 and 2 is not enough, so you had to do 3. Alright, and we're gonna test if it can hold up a book. From just looking at them right now, these are a lot more structurally sound and just more put together and they're stronger than the cube is. The cube wants to weigh, like I could probably throw it around and it probably fall apart, but these are they're a lot more stronger together. And I tried pushing them through more like I did these, and it just kind of keeps wiggling a little bit. So this is the book I have. It's a pretty decent weight of a book. It's a hardcover, so it should have some good weight to it. So let's go ahead and see. Just place it on there. Yep. You can see it doesn't completely mess it up because the toothpicks are pretty good into the gummies, but it's not very structurally sound. Maybe I can try to find a side. Maybe. Let me see if I can get a good view of this. When you place it down, you'll see it try to tilt one direction. If you try to, yeah, it's just not wanting to. So I would say that it's just wanting to go side to side because it's not like holding the weight on one portion. It's just kind of doing whatever, so it's really wiggly. I could understand if this was like if you're doing engineering, cubes and rectangles make sense. But if you're placing a lot of weight, one on top of another, maybe if it was like better materials, but just from this, it's just showing that a cube is not that strong. Now, if I use my pyramids, which I have 3 of, they're relatively as identical as I can get them to be. They all have square bases and all meet at the top for a point. What I think will happen is because all the weight that's placed onto that point will be distributed. I think it'll be better because this can't wiggle or anything like this one does. Like, so like if you hold it down, it just kind of does this, but like this one's obviously not going to do that. So I'm kind of doing in a layout like this because it is kind of weird shape. Look, kind of tilt it and then I'm going to place it on there. And that seems to be holding it pretty good. You can see it, there's 3 points where it meets and it's holding it pretty good. If I move the book around, it's holding it pretty good. Even if I yeah, it's got pretty good weight to it. While if I were to get this one and go, yeah, that pretty much destroys the structure. And you can do that from any angle. So I would say in this experiment, and even if it's applied to the real world, I feel like triangles are much better at distributing weight placed on top of them. Not that you would normally see a structure that has triangles and then just something flat on top of it. But I feel like for supports, this could be a really good way to do it. And for more new innovative engineering, I know this is kind of in-depth for just like a little candy thing, but just looking at the real world implications, this actually makes a lot of sense. And it's a cool experiment to see how the different shapes do this. It'd be cool to see some, like, if a rectangular prism would do better, but I feel like it would still do the same thing and move around. Yeah. But this is my experiment. Kind of put my conclusions in there. Overall, I would say that the pyramid is much better than the cube at holding the weight of the book. while it does take more of these, I feel like still, if I made more of these, is that what would happen is, imagine there's another one right here, I feel like it would still go in a direction, because even with these 4, it's not enough. Right, and that's my conclusion. This is my DIY candy engineering lab.